have learned this last class. Exponential functions. Okay? Now, we have learned so far that if my b value is greater than 1, I have a growth. If my b value was less than 1, I have a decay. We have learned that so far. Okay? Now, what we are doing is we're just going to extend upon that knowledge, and we're going to talk about how can we solve for the b value in a word problem. Because it is possible to solve for the b value when we talk about rate of growth or rate of decay. First one we're going to talk about is the growth. All right? So exponential growth is an exponential function in the form of f of x, aka y equals a times b to the power of x, where b is greater than 1 because we're talking about growth. Okay? If r is the rate of growth, aka a percentage, then the function can be rewritten as y equals a, and then the b value can be found by doing 1 plus the rate raised to the power of time. T will replace your x value. Okay? This kind of sort of looks familiar to simple interest, I think. It's very simple. No, not simple. Compound interest. It's close to the compound interest formula. Okay? So, first example here. The population of a city is increasing. If something is increasing, what are we doing? We are growing. So, we're going to use the exponential growth because the key word is increasing. Now, we are increasing at a rate of 4% each year. In the year 2000, there was this many people in the city. Write an exponential growth function to model this situation. Then find the population in 2009. So as you can see here, I wrote down 4 easy steps that we must follow in order to solve this problem. First things first is identify our labels. We've been doing that since day 1. The labels that we need to identify are A, R, and T. You will solve for the y value. So we only need to find A, R, and T. A variable signifies what? The initial amount. Okay, what was the initial amount of people since we're trying to find the population? 236,000 people. Okay, what is the rate? 4%. Now, 4% is the rate. However, in order to use the percentage in our formula, you must convert it to a decimal. Who can tell me how to convert a percent to a decimal? There's no math really involved. It's just doing one thing. Jordan. No. Brett?
Add 2 zeros.
No.
Move the decimal.
Move the decimal to the left 2 times. So right here I have the number 4. I'm going to move it over 1, 2. Move the decimal over 2 times. And now that is my decimal. Like I said, you don't need to do any math. It's just moving a decimal left 2 times to go from a percent to a decimal. If I wanted to go from a decimal to a percent, what would I do? Move the decimal to the right 2 times. You don't have to do any math. Just move the decimal. Time. So far we've identified the variables. Okay, find T by subtracting the years. So I want to know the population in 2009. How many years have passed from 2009 to 2000? 9. So T will equal 9. Now, we are talking about a growth in population, so the formula is y equals A times 1 plus, because adding means we're growing, the rate to the power of time. Again, this is very similar to our compound interest formula y'all learned in 8th grade. All right? So, let's do what we've been doing since the year 1983. What's the two things we do in algebra? Substitute and simplify. We have our labels, so let's substitute the formula. Remember, use the decimal form and the exponent of 9. Once I have substituted, what must we do now? What? Still solve? What's still solve? Solve. Let's simplify first. Okay? Can this little addition be simplified? Yes. Okay? I would rather write it, and you will have to write it like this on tests, quizzes, and homeworks. 1 plus 0.04 is 1.04 to the power of 9. Simplify the parentheses first. So just add them. What?
Why do we not distribute?
Why would we distribute?
That's what we've done every time.
Yeah, but that was when I had a value to a parentheses without an exponent.
Yeah.
This exponent changes everything. Yes. Yes. Now, in order to solve this, it is very simple math. We do 2, 3, 6, 0, 0, 0, parentheses, 1.04, close it, caret, 9. You just type it in the calculator. And then hit what?
Enter.
Enter. What do I have?
3359011.58.
Now, can I ask you something? We're trying to find a what?
Population.
Population is people. Can I have 0.5877 of a person?
No.
No. So I must round to the whole number. Whole number, because we're talking about whole people. Okay? If the number to the right of where I'm rounding to is 5 or more, we will add one more. So it's going from 1 to 2. 3, 3, 5, 9, 0, 2, and then we put our label. People. We're talking about people. It's all about the peeps. Questions, comments, concerns about growth? Y'all ready to talk about decay? Guess what? The decay formula is the exact same formula. The only difference is, instead of adding, we are going to subtract. That is the only difference between growth and decay with that formula. It's that simple. Okay? Process is still the same. We will label, we will substitute, we will simplify. So, label. I need an A, I need an R, and I need a T. The population of a city is decreasing, aka subtracting the rate, at a rate of 6% each year. So that is my rate. How do I write that as a decimal? 0.06. Okay? In the year 2000, there were 35,000 people in the city. Is that my A or my T? $35,000 people. Is that my A or my T? A. Write an exponential decay function to model the situation. Decay is y equals the initial value times 1 minus the rate to the power of time. Then I want to find the population in 2012. If the starting year is the year 2000, and I want to know in the year 2012, how many years have passed? 12. So there's T. Now again, there are 4 variables in the equation. We need 3 of them because one of them we are solving for. Do I have enough to substitute and simplify? Yes, thank you, Tim. Glad someone said yes. So I have y equals 35,000. Parentheses 1 minus 0.06 to the power of 12. Now I could simplify that. However, if I'm just looking for the y value, do I need to subtract that before I put it in the calculator? No, I can just type it as is. So there will be situations, however, where it'll give you a word problem and the answer choices are the equation, and in the parentheses it will have this simplified. So you got to know what's happening there. You just subtract or you're adding, okay? But see here I did the adding already, but I don't need to. 35,000 times 1 minus 0.06 raised to the power of 12. It will give you the same answer as if I did 1 minus 0.06 beforehand. Okay? What do I get?
1,665,721.
We are talking about who? People. Can I have 0.21102 of a person? No, a person is a person, no matter how big or small. We learned that from Dr. Seuss in Horton Hears a Who. So I am going to round to the whole number. The number to its right is less than 5. So this will stay. The rhyme for rounding. There's a rhyme for rounding. You may have heard it. You may not have heard it. Okay? The rhyme is 5 or more, add 1 more, 4 or less, let it rest. Elementary school. Okay? So that would round to 16,657 peeps. People. Right, Tim? Right, Brett? Did you write that down, Brett? All right. I'm just glad you covered your face this time. It's the nice thing to do. Do you have cough drops? Why do you have cough drops?
I have cough drops too.
Why is this like a thing now?
A lot of people have a cough right now. Never know. I have one.
She immediately just Checkers is just like evil cough.
I have one over the weekend. Oh yeah.
It's going around. The flu is hitting everyone pretty hard.
It's like coronavirus over.
Coronavirus is over. The flu has made his return. The flu has made its return.
Every year.
Okay. All right. Now that we got the cough drop situation figured out, all right, we are going to write a simplified exponential growth or decay function for each situation. Now, I'm going to do situation 1 and 2. The next page is situation 3 and 4, which is the one you will do. So this first one, I have an annual sales at a company are $372,000. That will be my A. It's increasing, so I have a growth at a rate of 5%. There's my R. So my equation will be y equals the initial value, where I have 1 plus the rate because we are increasing growth, 1 plus 0.05 to the power of t. So there's my equation. Now you could write your equation the same, okay, except you could have 1.05, aka simplify the parentheses. That could also be your answer as well. All right. Now I will answer the question. I have 8 years. That is my time. Okay, so I will take 372,000 times 1.05 raised to the power of 8. When we type that into the calculator, we get sales, which is money, $549,613.43, because money always goes to the hundreds place. Problem number 2, monthly car sales for a certain type of car are $350,000. That is my A. They are decreasing, so I have a decay at a rate of 3%. There's my R. I only need R and A right now. So I have Y equals 350,000 times 1 minus the rate, 0.03, to the power of time. Again, compound interest type formula. This time we're losing money in our bank account. What will the value be in 6 months? Now, if we notice something, my rate changes per what?
Per month.
Per month, okay? So when I take 6 and I substitute it in for T, I just need to put literally 6 because it's months and months. Now, what if I said 3% per year? What if I said per year and down here I said 6 months? What would I need to do to this so I can put it into the equation? I have to convert the months into years, right? How many months are in a year? 12. So I would have to do 6 over 12, which would be a 1/2 year. This isn't, we're not doing this 1/2 in this problem. I'm just giving you a heads up. Please make sure you are checking the labels. If it says 3% per month or per year, and it gives you months as your time, you must know how to convert. Okay? That's not what we're doing in this situation. It's month to month, so we're good. 350,000. 1 minus 0.03 to the power of 6 because it's month to month. Who can tell me that value? Say it again. $291,540 and 20 cents. It is now at this time that I'm going to ask you to turn the page and do questions 3 and 4 on your own. Then we will spin the wheel of not ideal for you to show me your equation and show me your answer. 3 and 4, the 2 questions at the top. The questions at the top.
Clearly.
Yeah. Is that?
Right there. Oh.
Tim, do you know what grade level is?
Yes, I know.
Yeah. It's bad that you know.
I know what it is.
I know, that's a bad thing. It means you've been there a couple times. Lucas, do you know what grade level is? Aw, dang.
Not bad.
Not for bad reasons. Now look at me with this opportunity. Oh, TikTok going off. $540 followers. 660 more followers, or 460 more followers. I can start monetizing.
We'll get like 1 cent.
I know, 1 cent on the dollar. Oh, Kamara's back.
I forgot what the rate is, but
I know those.
It's like per 100 views or something like that. Yeah. I didn't do attendance. All right, let's see here. Lisa's here, Lucas is here, Brett's here, Jack's here, Jordan's here, Addison's here, Xavier's here, Kamara's here, Connor's here, Riley's here, Jose is here. I just lost my place because my eyesight is horrible. Tim is here, Ben is here, Alexa's here, Kenzie's here, Corbin is finally here but asleep, Checkers is here, and Elva's here. Sweet, everybody's here. Time for the Wheel of Not Ideal! Oh, where's the sound? He's in the restroom. Isa! Please give me your equation and answer on number 3. No. Go up there.
you have to go up there.
You want me to blurt this out?
No, you write it.
Write it down.
Oh, okay. This is my equation.
And our answer is...
The answer is...
Alright.
It's not right.
What was that sound?
It's not right?
It is right as long as you add one more thing to that, aka the label of your answer. So add that to our answer. Like write it. Yeah. Sweet! That is 100% correct. Lucas! Issa, you almost got chosen again. You almost got chosen again. You can take your paper up there with you and just copy what you wrote. Lucas. For shame.
This one,
Yep. I think exponential functions is actually one of the easier functions out there.
And this? Like this is.
No, like this is like all these like we're in exponential functions right now, and there are several of them, but they're like
There's just a lot to remember. A lot of them.
there's a lot of formulas to remember. Luckily, most formulas are on your star chart.
Yeah.
Bum, ba-ram, ba-ba-ba-ba-ba-ba-ba-bum, bum, ba-ram. Ba-ba-ba-ba, ba-ba-ram, bum, ba-ba-bum, bum, ba-ram, bum-ba-bum. You alright, Connor? You alright?
Oh my god.
Got a little headache?
Good job.
That is 100% correct. Anybody have any questions on those two?
No.
Sweet. Can someone go erase the board for me, please? Because we're going to finish the last part. Thank you, Kinsey. Given the following exponential function, identify whether the change represents growth or decay. Determine the percentage of rate. Determine the percentage rate of increase or decrease. So, the first few problems we've done, I've given you the percents. This time, I give you the problem, and you need to tell me what the percent is. Now, there are two main things we need to remember. The first thing we need to remember is if my b value is greater than 1, I have a growth. If my b value is less than 1, I have a decay. That's our big things that we need to remember. Now, when I have a growth, to solve for the percentage, you will do your b value minus 1 to give you your percent. If you have a decay, you will do 1 minus the b value to get your percent. Okay? So in this first example, my b value is what's connected to the exponent, aka the parentheses. That number, is it greater than or less than 1? Less than 1, so I have a decay, which will be a decrease. Now, to solve for the decay percentage, I will do which of the two formulas? Top or bottom? Bottom. I'm going to do this one because we identified it as a what? Decay. So I'm going to do 1 minus the b value to get that decimal. What is that decimal? No. 0.02. However, I want the answer as a percent. We know how to go from a decimal to a percent. Why are you holding up 2? How do you get 2?
Because you move the decimal over 2, or to the right, by 2.
To go from a decimal to a percent, you will move your decimal point to the right 2 times. So to go from a percent to a decimal, you move to the left. To go from the opposite direction, you go to the right. So my answer is a 2% decrease. Right, Jordan? How do I what?
You get your percent by doing 1 minus.
The b value. That is for decay.
And if you grow,
If I have growth, aka example number 2 here, is that number greater than 1?
yeah.
So I have a growth, right? Which would mean my percent is an increase. So if I have growth, what am I going to do?
Plus 1. Wait.
To find the percentage,
Oh.
I'm going to do the b value minus 1 because I'm trying to solve for the rate. I'm trying to solve for r. Okay? So remember, this is technically negative 3 times 1 plus r. Okay? I need to figure out what did I add to 1 to get 1.75. Okay? What was the rate is what I'm trying to find. To find the rate, you do the b value, 1.75, minus 1 to find the difference. What's the difference between these two? 0.75, right? So I need to convert this to a percent. So I move my decimal 2 places to the right to get a 75% increase. It's very simple. To make things a little bit easier, here's what you would do. Okay? You take your b value and you find the difference. Your difference should always be a positive number. So you're either subtracting from 1 or you're subtracting by 1. The whole goal is to get a positive number to solve for the rate. That is what we're solving for. That is what we are doing. Ipso facto, conundrums of blowsystems, and